I am. Sorry. Hello, everyone. Thanks for your time joining us today. So first, who are we? We are a team of 16 Android engineers, teammates from 10 nationalities, plus one bottle. There is 4 sites, Paris, Berlin, US, and China. We are an Android app in 6 languages, an app with more than 9 million installs and 1.4 million active devices. And we are proud about our crash-free rate, which is around 99.97. Who am I? My name is Rami. I'm a senior Android engineer working with Core Mobile in Vestiaire and the Android design system lead. These are my LinkedIn profile and my Twitter if you want to reach out. So just those 2 pictures to say that we are a passionate team loving Android. And today we're going to talk about building a design system from scratch at Vestiaire, following atomic design as an approach and with Jetpack Compose as a toolkit. So first question that can pop up here, what is a design system and what is atomic design as methodology? We'll try to understand together those exciting concepts. So first of all, how did we arrive here? So in the early days of tech products and apps were seen simply as a collection of individual pages. Almost every screen would have unique elements that ended up with a design being inconsistent and unintuitive. So to deliver well-designed products, several companies started thinking of a process that can structure the design and speed up the delivery. So what is the definition of a design system? A design system is a set of standards to manage design at scale, but by reducing redundancy while creating a shared language and visual consistency across different pages and channels. So very similar to Lego blocks, it's a set of pieces that can be repurposed in an nearly infinite paths. There are many ways to approach the creation of a design system. Atomic design is one of the methodologies that was trusted for its coherence. So what is atomic design? Atomic design is a design approach that was invented by the American web designer Brad Frost in 2013. So it is no longer a question of designing static pages like a book that remain frozen in time, but rather the trend is converging towards the creation of scalable and innovative interfaces. It is an iterative and non-linear approach. It is iterative because, as we can see here, it's starting from atoms going to pages, and it is non-linear because the atoms can be used anywhere in the tree. Atomic design wasn't a frozen concept. Frost describes atoms as elements that cease to be functional when broken down further. So he classified buttons, for example, as atoms for this reason. But here is where the confusion starts. What is an atom or not? A button, is it an atom? After 6 years, in 2019, seeing some limitations of the methodology, Brad Frost published a new article talking about extending atomic design. In this publication, a new concept was introduced, which is design tokens. We'll see more of that, what are the design tokens in the following slides. So with the new evolution of atomic design concepts, in Atomic 2.0, only foundational elements foundation styles are atoms because they truly cannot be broken down further. So anything in the atom category can be turned into design tokens. With this approach, the atoms can only create a molecule when combined with another atom. So a button, being a combination of color, text, and spacing atoms, would be considered as a molecule. So we can see the transformation through these two illustrations. So out of Bradford's shift of structure, we needed to agree on something. So in a nutshell, for us, elements of atomic design can be defined as following. So the tokens are the foundational elements, such as colors, icons, and typography. Components are the most simple elements, for example, a button or a text. Patterns are more of a functional grouping of components, such as product tile, tooltip, or a bottom sheet. And blocks can be a slice of a page with patterns and components inside. And templates are simply page templates. Let's try to understand this more by breaking down an example. So we can start composing from tokens as an icon, color, typography, and spacing, like here. To have a component as a button, you can see in this button it has the color black. It has some spacing on the right, left, top, and bottom. And it can have an icon, and it has a typography here. From those, we can create like a pattern, which is the product tile. We can see the button in here. We can see the tokens everywhere, so the icon is there, for example. And with this pattern, we can create a block like this part of slice of a page, which has an horizontal list of product tile. And with this block can be placed inside a page template, which is here, in this case, the product page. So if we recap with many examples, tokens can be like in this illustration. So here there is the colors, the icons, spacing, and typography. Components can be tags or badges or buttons, as we have seen. Patterns can be product tile, as we have seen before, or tooltip. Tooltip is an education message when there is a new feature. Blocks can be the part, the top part, for example, of a profile page, or this grouping of buttons on the PDP, on the product page. And templates can be a complete screen structure, like the welcome page of the listing form. Since our focus in this presentation will be about implementing the design tokens, so in few words, what are the design tokens? Tokens are the beginning of everything in the design system. Any small change on them can trigger a ripple effect in every area of the system. Tokens are the smallest pieces in the design system. Their primary function is to store UI information. A token is an immutable element that requires a well-defined modification process. A token is also a raw material that we use to build more complex elements, like components or patterns. Some examples can be visual, like those ones, or non-visual, like animations or motion guidelines. So before seeing how we started building our design system from scratch, let's have a look at what we had before in the code base. It's going to be fun, I promise. So, what was in the code base? The patterns we had, nada. The components we had styles like for this primary button. I guess it talks to any one of us as Android developers. That we did override like this, adding another text color or corner radius. So here we can see there is no immutability that is guaranteed here. And there is many other problems. So Android styles aren't components. Android styles are mutable. We can inherit and override with every change in the design. Consistency is lost every time a new UI is built. And for every new UI, we reinvent the wheel again and again by creating a specific layout and specific components and patterns. So here we can see also productivity is not favored. And to finish with the design tokens we had started by colors named like this, so gray 1, gray 2, gray 3, gray 2, 36. That were redesigned in 2017. You can see soft black, light gray. And in 2020, again, another way of definition. And we ended up with, again, another way of defining the variables. This time it's in camel case, and you can see the color problem, which I guess it's a problem. So, we've seen the past. What about now? Let's dig on the implementation and delivery of our design system, Accent, and how Jetpack Compose helped us to do that. So in order to create a well-defined design system, we need a plan, and the plan needs a strategy. So let's talk strategy. So in order to deliver Accent, it's our design system name. I guess you guessed that already. So we estimated our milestones of work as following. So in milestone 1, what was achieved, Accent defined and the guidelines are written. Project structure is set up in the code base. Design tokens are defined and implemented in code. And initial components and patterns also are defined. For milestone 2, we're planning to have new features, start adopting Accent, and feed it with the new implementations. We implement all the initially defined elements of the design system. We use semantic versioning for each new element added to the system. Later on milestone 3, we want to document insights about what worked well as components and patterns, and start replacing the legacy UI. And new features systematically use Accent and feed it. So also another point is we want to Accent design system to become an artifact repository that all of our apps can consume. Just to say that each milestone is around 1 to 2 quarters of work. Now, since this is what was achieved, we will focus on milestone 1. In milestone 1, we started by doing an RFC. An RFC, for the ones that don't know that, it's a request for comments document. You can see its summary in this screenshot. This document is meant to propose a technical plan with methods and research, then gather all the feedbacks from the team. So we share it as a merge request and come out with a solid plan after the feedbacks were taken care of. Then the second step is find a cool name. So I found Accent. A lot of discussions, I guess, with designers, defining the concepts with the team, exploring and benchmarking open source design system built for Android, preparing some bugs, then start building. Talking about the name of Vestiaire Collective's design system, it's Accent. So in the phase of benchmarking, we found very cool names for popular design systems. Like for Netflix, they have Hawkins. It's a reference for Stranger Things, if you have seen that. For Skyscanner, it's Backpack. I see it's smart name. Decathlon, they have Vitamin. And by the way, both of the design systems are open source that you can check out and you can see its wonderful work there. For us, since we are an international company and we have a lot of accents, we went for Accent as a name. Okay, for Accent implementation strategy, our key choices are the following ones. So focus on 4 tokens, which are icons, typography, colors, and dimensions. Use the atomic design approach. Go all in with Jetpack Compose. Follow material design guidelines and leverage Compose Interoperability APIs for the view system. So, as we said, we decided to create our design system following material design guidelines. So this means that in Vestiaire code base, we have Accent theme, which is built following material theme implementation, but with its own subsystems. Those subsystems also map to the structure requested by each of the material subsystems. We still can use material theme if we want to retrieve one of the predefined variables, like this line of code, material theme.colors.primary variant, for example. I understand that this looks a bit complicated at first sight, so that's why we'll get everything explained in next slides. Starting by compose material. So compose material, or also its name is material design components. It's here, coming easily as a Jetpack Compose library. It is considered as a design system by its own that is ready to use. It is composed of 3 subsystems, so typography, color, and shape. So if we take an example here from this diagram, a button can have a color from the color schema, medium shape, and the text with Roboto fonts. And this setup works, for example, in light mode or dark mode. So we pick from each schema, and it will pick on the right color palette for dark or mode, dark or light or other. So I won't go a lot on the technical details, but a very good place to look at in the documentation is Jetpack Compose Anatomy of a Theme. But we will be back to compose materials, technical structure, in code in the next slides. But we said we're going with atomic design methodology. So let's see first how we built our tokens, then how we made both systems cohabit and communicate with each other. First of all, to build each of our tokens by code, these conditions needs to be met to consider it done. So specifications need to be ready design-wise. A section how to work with is added inside the design system guidelines with each token created. A sample code is ready, showcasing the token implementation. Within each implementation, design QA is done to validate it. And a screen is added to the Accent Companion app, which showcases the token in different configurations. Talking about Companion here is a screenshot, but let's see more of a video of how it works. So you can see all the tokens are implemented, each with one screen, and inside the screen the different configurations. What the Companion app helps us to do. So it showcases all the accent content, its version, and the progress of work. It's a validation tool for designers. Its module contains code samples for how to use each element of the design system in code according to its different configurations. And it's not included in the release builds. And this is done by having a no-op module. No-op is short for no operation, and it signifies a computing operation that has no significant effect. Okay, we have seen many things now. I guess now what we want to see is more of code. So in the next parts, we'll talk about Jetpack Compose interoperability, compose material, composition local, and accent theme and tokens. First thing, compose interoperability. So if we want to have compose in our fragments, it's as simple as adding this compose view. Then we can retrieve it in our fragments or activities and add any composables we want. But if you hate XML in Android, and I guess you do, so in a fragment, we can get rid of the XML layout and return directly a compose view. And inside this compose view, we define the root composable as the material theme. You can see it here. Then we add all the composables. So text here, it's a composable, and we can add many other composables. It's important to also to highlight the fact that we need to it's important to dispose the composition when the fragment's life cycle is destroyed. It's not done automatically. So by this line, set view composition strategy to dispose on view 3 life cycle destroyed, we'll dispose it. Now to start composing the design system, let's understand first the material theme composable that we have seen that we used in the root of the composition. Just as a note, this code is from the Android SDK. So if we add compose material as dependency to our project, we can access the material theme class. So material theme is the top hierarchy composable that is used to wrap all the rest of the composition. It provides defined colors, typography and shapes for composables under its umbrella. That can be a text, button, a toggle, whatever. In its signature, it's defining default values for colors, typography, and shapes by calling statically material theme.colors, material theme.typography, or material theme.shapes. Let's understand what is this material theme object, or singleton. So material theme object here is a singleton that returns for each of material subsystems a composable that has inside local colors .current, for example, or local typography .current. So what is this local colors? Local colors is it's a static composition local of colors, or light colors. It's the same class, it's just a method returning colors with predefined colors. You'll see the signature of colors class later, but now let's try to understand together what composition local means. So composition local is a tool for passing data down through the composition implicitly. So it's used to pass, here in our case, it's used to pass down theme subsystem for the disposal of the composables under that theme. So it is also like that we can, for example, get the Android context by simply calling local context.current anywhere inside the composable code. That's why it is implicit, no need to pass a variable as method parameter for the composable. So we can forget passing context as an argument. And that's why it's implicit. There are many other existing local compositions. We can just go to Android Studio and start typing local, and you will see something like this screenshot. Now we've seen what is composition local and how material theme is built under the hood. More specific to our case, how we are building accent theme. So you can see that we're using composition local here also to pass down the data, the color system and the typography system. And we're defining our root composable as accent theme that is encapsulating the material theme like this. And we're using these extensions, so accent typography system to material typography, and accent color system to material colors. So these both extensions map between both systems. This looks a bit like magic. We'll have a look together on how this mapping works for each of the subsystems. But just before, let's continue to see the accent theme object. So accent theme is created as an object, very similarly to how it's done on material theme. And this is done to be able to access statically colors, shapes, and typography by just calling accent theme.colors, for example. So it's clear that it's just wrapping the composition local of each of the subsystems, so accent color system or accent typography system. So in a nutshell, it makes a quick access to the current implementation of the composition local of the subsystem. I hope it's clear now on themes. Let's see how each of the subsystems is created. So here, first subsystem and token, it's the color system. We're just seeing the accent color system. Here we're defining the accent color system as a data class containing a final set of colors, each of type accent color. Accent color, we can see it on the right here. It's a class defining the color entity. So here, for example, the G0 in grayscale, it has as arguments its name for accessibility and the color definition. Any color possibility to use in design and in code should be part of these attributes. Here we can see the implementation in the companion app. Now about the extension that we have just seen before. So accent color system to material colors helps us communicate between both systems. This extension, when used, it returns an instance of colors class initialized with colors that we have chosen and attributed to. The class colors has as signature the definition of the material palette that we can see here in the middle. These colors, like primary or secondary or surface, provide defaults. So for example, whenever you use, let's say, a radio button in our UI, it will take the default color, the color when it's clicked. It will take it as the color secondary that we defined here as grayscale G100, let's say. So same here about the typography system. We can see it in the companion app. And accent typography system is also a data class wrapping all possible typography styles. So each typography style is defined as a text style that contains all the needed attributes on one shot. We can't override, and we need to use directly as such. Here is an example of usage in an accent text. So here the accent text provides a contract that doesn't allow modification of any of the attributes of the text style. So we can't pick A40, for example, and override, I don't know, the font size. So if one of the attributes like the font size or line height are different, that means that we're not looking at the right typography style to pick, and we can double check on Figma or talk to one of our designers. Similarly to colors, here we're mapping from accent typography system to material type scale. The extensions, this extension returns an instance of the class typography that represents the material scale of typographies. So this definition will provide the default text styles for any text in the app that didn't have the unattributed text style. So in another example of usage, here we can see that we're using material theme instead of accent theme. So we said that we can use both. Third token is accent icon. So we can see it in action, again, with here different configurations. So we created the composable accent icon, which has a contract also that doesn't allow to use any other icon that is not inside the accent icon asset. So this is made to restrict the choice of an icon to only what accent library of icons provides. Accent icon exposes also the possibility to choose the size or to make a tint color. Now let's see what is accent icon asset. So it's as simple as it's an immutable class that has as arguments the name for accessibility and the icon drawable. And we can access any of these predefined colors via its companion object. So also here the set of icons is final. Now finally, the fourth and last token definition. Accent dimension is a representation of all possible dimensions to be used in the UI elements. Same here, it's final. And when I say final, this means that if we want to add another dimension, it's just that we need to iterate on the version of the design system. So here, the dimensions are composed of spacings, icon sizes, image sizes, image aspect ratios, border radiuses that we can use with shapes, and that's it. Now, tokens are implemented how to contribute to accent. So, collaboratively with our designers, we did an analysis of our Android app UI, and we came up with this pre-selected list of components and patterns. So we can see how we are describing them, how we are splitting in different columns. The tokens, we already talked about that, colors, typography, icons, and spacing. For components, we have chosen badges, for example, because we use them on the product tile or in many different UIs. The toggles, checkboxes, buttons, so they will be the button from material design is button, for example, and we have accent button, accent text, accent slider. And for patterns, we're still defining, so this is just the version 0, let's say. And we have chosen the product tile, the skeleton tile, the search bar. The idea now, after having integrated all the design token, is now about the methodology is whenever a new feature will be developed, it needs to identify first the components and patterns needed for the UI to be built first. Then a task is created to create those in the design system. Then the UI of the feature will use it. And later on, Milestone 3, we'll consider replacing the legacy UI of the app by the design system elements. So that was the implementation. This is the last part of the presentation. We'll be talking about a dangerous concept, which is called design system graveyard. But don't be afraid. We'll see together how we can avoid it. So what is a design system graveyard? It's called design system graveyard when companies have created design systems or perhaps pattern libraries that are no longer in use. So when I interviewed these companies, the common answer was because it didn't fit. Possible reasons can be the patterns defined don't meet the requirements of the actual product design, or the design system was created independently in a completely different context from the existing product, and the components were more of first fit to be applied to. So let's see first what are the criteria of good components. From the book Expressive Design System, the condition for a good component are: 1, components should solve a specific problem. So they should be defined by their purpose, not by how they look. 2, components should work for multiple use cases. There should be few components that only work for a singular use case. 3, components should work in many different contexts. If we design components that are too rigid, people will create their own components, and this will end up with a bloated system. Sometimes it's common to have some sort of confusion between a pattern and complex component. So components are simply UI elements that we use in many layouts. The only context of its documentation is its self-definition, whereas patterns are a bit more of that. They provide a specific context about a solution. So as an example, for the difference between a complex component and a pattern can be the product tile. So product tile is product definition according to the context defined in our understanding of e-commerce. So product tile in Vestiaire, it's not the same than in Zalando or anywhere else. And this is a pattern. A complex component can be a card container, as we see here. A card container can have many different configurations and can be reused in other products as simply as a layout structure. Can create it, and it can be used in another products. So now about consistency. Not guaranteeing good consistency can make a design system fail. So what is it? Why is it needed, and how consistency makes users happy? Simply because it reduces the cognitive load. So users don't like to think, to take actions. That's why reusing some patterns in the app is good for them. So for example, everyone is used to closing a dialog from the top right corner. Changing this pattern to make it close from the bottom, for example, makes the user have to think about the action to take, which may prevent them from doing some actions. So that's why the design system is very beneficial to create patterns that will be reused through the app. So that's why consistency is good. However, we need to be careful, as it can become harmful sometimes. So applying consistency shouldn't be a religious rule. It can be harmful. Consistency is effective only when patterns and component variations are defined for different purposes. We can see in these two examples, one original design and one first consistency. On the second picture, the card has lost its clarity about the discount. So sometimes engaging some of the user cognitive load in favor of a clear purpose, like in the picture, the discount here, can be a defined state of the configuration of the pattern. So you can say safely, it can make, if you can make something significantly clearer by making it slightly inconsistent, choose in favor of clarity. Clarity trumps consistency. Now, to recap, a design system is meant to increase scalability while improving design quality. So consistency is the means to that end, or the way to make our journey a success. Productivity is the result, not the purpose. So it will happen naturally when the design system takes its place. Now to finish with these closing words, a design system not only increases productivity and consistency, but also enables a better user experience with lower cognitive load. It allows more time for the creative part of the project by avoiding reinventing components and patterns that were already created and validated. Thanks for your attention. Feel free if you have any questions.